Hey everybody, this is Mr. Beckstrom, and today I want to take a look at a question from section 8.2, and this is number 10, and it says an aircraft at sea, and this is right up here, is spotted by two observers at X and Y, so one observer here, one observer there, who are L equals 1650, so they're 1650 feet apart from each other, so this distance here. As the airplane passes over the line joining them, that's the L line, each observer takes a sighting of the angle of elevation. Remember, the angle of elevation is the angle from the horizontal line, so that would be this line L going upwards. So that would be the angle of elevation would be this angle here from X, and this angle here B from Y. To the plane as indicated in the figure. If A is equal to 45 degrees and B is equal to 45 degrees, how high is the airplane? All right, so we have a triangle here. Now, first of all, with this particular triangle, if this is 45 and this is 45, this has to be 90 degrees, which means this is a right triangle, and this makes this question a whole lot easier because then we can actually just use the Pythagorean theorem to solve it, because really then these two sides have to be the same length, because this is also an isosceles triangle since these two angles are the same. So you can have like a squared plus a squared is equal to c squared, and we know what that is. So we can pretty easily solve for these sides and then find the height. But we are in the section for law of sines, and I do want to show you how to do this if we have any different angles for A and B, not just when we have a right angle here. So we will go through a different method for finding this that'll work for other angles other than right angles for up here. Okay, so how do we do this? Well, notice that for this smaller triangle here, this is also a right triangle when we drop this line vertically straight down to make a right angle with L here. So with this smaller right triangle, we can set up one of the trig functions, right? And we have h here. So we can either use this distance going from x to where it meets here, or we can use the distance going from x to the plane up here. But what we're really trying to do is we're trying to find the distance. That's what they're asking for, right? How high is the plane? They're asking for this distance there. So we can either set up a tangent function, which is opposite over adjacent, or we could set up a sine function, which is opposite over hypotenuse. It looks like the sine function might be the way to go, since it looks like we have a clear ending point here, and down here we don't really. So I'm going to go with the sine function here. So the sine, oops, let me put it in pen mode here. So in this case here, the sine of A is equal to opposite, that's the h side, all over, and this would be the hypotenuse. Now remember, if this is angle B, big B, then the opposite side, the side that's not touching, is going to be little b. So we'll mark that as little b, and this is little a. And this side here, if this is big Z, we'll call this one little z over here. So this will be opposite over hypotenuse, which in this case is little b. So, and we want to solve for h, so I can just multiply both sides by little b, and I'm going to get h is equal to little b times the sine of big A. All right. Well, we know what big A is. That is 45 degrees here. We just need to find out what little b is there. So let us go ahead and write this entire triangle and see what we have. So I'm going to go put this into ink to shape there. Let's see if it will actually do a triangle for me. So do. Look at that. Nice triangle. All right. And we're going to mark this with what we know. So we know that this is 45 over here. We know this is 45 over here. We know that this is 1650. 1650. We know that this is 90 degrees, and we know that because all the angles add up to 180, so 180 minus 45 is 90 degrees. We don't know what this side is. We don't know what, oh, that should be B over there. So we don't know what B is, and we don't know what little a is. And really all we need for this from this one is the little b in order to put in our equation so we can solve for h. So in order to do that, we know this angle and this opposite side, and we know this angle. So that tells us we can use law of sines because we only have one unknown, so we can use that. So law of sines, it says that we can take the sine of an angle, so we do the sine of 45 degrees over its opposite side, so over b, is equal to the sine of another angle, so the 90 degrees. 90 degrees over its opposite side, over 1650. 1650. So I only have the one unknown here, so this will be nice and easy to solve. So when you cross multiply and you divide, you're going to get b is equal to 1650 times the sine of 45. Sine of 45 all over the sine of 90. And we know that that's just equal to 1, right? So let's see what that's going to give us. Make sure we're in degrees. We are. So that's going to be 1650 times the sine of 45 times the sine of 45. Enter, divided by the sine of 90, which we already know is just 1, but I'll put it in there just to make sure. So that's the same thing. So it's about this amount here, but I'm going to go ahead and keep that in my calculator. So that's my B. So all I need to do is multiply that B times my sine of A to get my H. And so that, and my A is 45 degrees. So I'm just going to multiply that answer by sine of 45 degrees. And I get 825. So H is equal to 825 because it is equal to B, which B is 1166.726.189. I'll go ahead and you can write all that out there, and then you plug that B in there. Sine of A is 45 degrees. So you plug all that in there, and you'll get H is equal to 825. So the height of the airplane is 825 feet. Now I want you to notice something here. This is an isosceles triangle. It's a 45-degree angle, which is half of a 90-degree angle. The length going all the way across is 1,650 feet. And what is half of 1,650 feet? Well, that's 825 feet. So that angle or that distance up is exactly half of the distance across, and that is not a coincidence. So they gave us really nice angles to do this with, and like I said before, we could have done this a lot easier if we would have just said, hey, I know that A and B have to be equal to each other because this is an isosceles triangle and it's also a right triangle. So I could have just set up the formula a squared plus a squared is equal to c squared, or 2a squared, right? 2a squared is equal to this length here, right? 1650. 1650, or a squared is equal to 825. 825. We could have ended up at least, what would we do? Find the A or the B that way, and then ended up finding the height that way. All right. If anybody has any questions, let me know, and I hope you have a great rest of your week. All right. Thanks a lot. Here's your answer. All right. Bye-bye.